All right. We got day 10 of the Advent of Cyber. Today is SQL injection. Inject the halls with EXEC or EXEC Queries. Let's go ahead and jump over to the box and see what we got going on. All right, we've started up our attack box. We've got our machine started. Let's go ahead and read through the story as we continue on through the Advent of Cyber. The Best Festival company started receiving many reports that their company website, bestfestival.thm, is displaying some concerning information. About the state of the Christmas this year. After looking into the matter, Santa's Security Operations Center confirmed that the company website has been hijacked and ultimately defaced, causing significant reputable damage. To make matters worse, the web development team has been locked out of the web server as the user credentials have been changed, with no other way to revert the changes. Elf Exploit McRed has been tasked with attempting to hack back into the server and regain access. After conducting some initial research, Elf Forensic McBlue came across a forum post made on a popular Black Hat hacking forum, Jingle Hacks. The post made earlier this month explains that the poster is auctioning off several active vulnerabilities related to the Best Festival company systems. All right, let's see what those are. Looks like we have a little note in here. Hello, Jingle Hacks forums. As the merger of Best Festival company approaches, I find myself in possession of knowledge that's as good as gold. I've decided to auction off these vulnerabilities to the highest bidder. The stakes are high and the potential rewards are even higher. If you've got the skills and resources to make use of this information, you're in for some serious paydays. I won't reveal all the details here, but I can confirm that these vulnerabilities are both 0 days and known issues with Best Festival company that the Best Festival company has not addressed. The treasure includes potential entry points, data access, and even the possibility of exposing some classified information. To bid, reply to this thread. Okay. This forum post surely explains the havoc that has gone on over the past week. Armed with this knowledge, Elf Exploit McRed began testing the company website from the outside to find the vulnerable components that led to the server's compromise. As a result of McRed's thorough investigation, the team now suspects that this was done by a possible SQL injection vulnerability. All right, we've already done this, started up our attack box. All right, so what is SQL? SQL is a structured query language, is essential for working with relational databases and building dynamic websites. Even if you've never explicitly used SQL before, chances are you frequently interacted with databases. Whether you're checking your bank account balance, browsing through products on an e-commerce website, or posting a status on social media, you're indirectly querying and altering databases. SQL is one of the most popular languages that make this all possible. Let's see. Relational databases are structured data collections organized into tables, each consisting of various rows and columns within the collection. Tables are interconnected and with predefined relationships, facilitating efficient data organization. So you can kind of see here, we've got our customer ID, which relates to the customer ID of the table of orders. We've got our customers table, we've got an orders table, we've got a product order. But you see we've got IDs all around that are relations. So this customer ID is relating to this customer over here, which relates to that product over there. What's up, guys? All right, SQL provides a rigid way to query, insert, update, and delete data stored within these tables, allowing to retrieve data, alter databases as needed. A website or application that relies on a database must dynamically generate SQL queries and then send them to the database engine to fetch the data that is necessary. The syntax for SQL queries is based on English and is consistent of structured commands using keywords like select, from, where, and join to express operations in a natural way. Let's see what we got here. We'll leverage an example of a database table to represent the tracking and the cataloging of the Christmas tree ornaments. The table, it looks like we've got ornament IDs here. So 1, elf ID, 24, colors red, categories ball, glass, blah, blah, blah. $5.99, expensive ornaments. See if we can't fly through some of this. In a simple example above, we have defined the database table as table ornaments to store ornaments with various columns. We can run various SQL queries against the table to retrieve, update, or delete specific data. For example, we can run a select star, which means select all, from the table of ornaments where the material equals wood. So anything in the table of ornaments that is made of wood is basically what that query is going to run. Select ornament ID color category from table ornaments where elf ID equals 1 or 2. So basically for that one, we're going to select the ornament ID color and category as our columns, and only for the ID of elf for 102. This statement will return the ornaments created by elf ID 102. Unlike the first statement, this query only returns the ornaments ID. Let's see our next one, insert into table ornament. So basically we're adding to the table, insert into table, ornament ID, elf ID, color. So those are the values. So our ornament ID is going to be 5, elf ID is going to be 105, the color is blue. Category will be star, material is going to be made out of glass, and then when it was created, and then the current price. So that inserted in. All right, take a quick look at what PHP is. PHP is a popular general purpose programming or scripting language that plays a crucial role in web development. It enables developers to create dynamic and interactive websites by generating HTML content on the server and then delivering it into the client's web browser. PHP's versatility and seamless integration with SQL databases make it a powerful tool for building feature-rich dynamic web applications. PHP is a server-side scripting language, meaning that the code is executed on the web server before the final HTML is sent to the user's browser. Unlike client-side technologies like HTML, CSS, and JavaScript, PHP allows the developers to perform various server-side tasks, such as connecting to a wide range of databases, and there's all the databases in there, executing SQL scripts or SQL queries, processing the data, and dynamically generating web content. We've got our nice little infograph here that kind of shows what's going on. Let's see. The most common way for PHP to connect to the SQL database is using PHP data objects. Extensive and specific database server drivers like MySQI, MySQL for SQL Server, and for Microsoft Server, SQL Server. The connection is typically established by proving parameters such as the host, username, password, and database name. After establishing a database connection, we can execute SQL queries through PHP and dynamically generate HTML content based on the returned data to display information such as the user profiles, products, product listings, blog articles, basically anything. Returning to our example, if we want our PHP script to fetch information regarding any green colored ornaments, we would introduce the following lines: query equals select from all ornament table where the color equals green, and then our result would be the SQL server underscore query, and then the query connection to, or the connection to the actual query run on the server. In the snippet above, we first save our, just started to explain this. In the snippet above, we first save our SQL query into the variable named query. This query instructs the database to retrieve all rows in the table ornaments where the color column is set to green. Then we use the SQL server underscore query function to execute this query by passing it to the database connection object con. You can think of the $result variable as a container that holds the outcome of the SQL query, allowing you to iterate through rows and access the data within these rows. Later in the script, you can use this result object to fetch the data We've got user inputs. Don't really need to go through all of this. All right, so the above snippet of the color variable to the retrieved value of color URL parameter, the variable then gets passed to the query string. So no, they're not really showing it. Oh, they're showing it down here. Okay. Now users can dynamically control the query being executed by the database simply by modifying the URL parameter they include. So this is more or less what we're going to be working with here. So we've got our URL with HTTP, the example of the domain, and then what we're doing ornament search.php, and then we're going to look for just the specific color, and that's showing you basically what it's doing. Color equals get that color from the table ornaments where the color is green, and then it shows you all the greens. Quick and simple. So SQL injection, I guess we kind of really need to go over this real quick. SQL injection, taking in user supplied input gives us powerful ways to create dynamic content, but failing to secure this input correctly can expose a critical vulnerability known as SQL injection. The SQL injection is an attack technique that exploits how web applications handle user input, particularly in SQL queries. Instead of providing legitimate input, like the ornament color in the example above, the attacker injects malicious content into the SQL statements, into the web application input fields, or into the parameters. The application's database server then executes this rogue SQL query. SQL injection vulnerabilities pose a considerable risk to web applications as they can lead to unauthorized access, data theft, data manipulation, or even the complete compromise of a web application and its underlying database through remote code execution. If an attacker can control which queries the database executes, then they can control the database functions performed and the data returned by it. As such, the impact can be catastrophic, ranging from exposing sensitive user information to causing significant data breaches. When a web application incorporates a user input to SQL queries without the proper validation and sanitation, it opens the door to SQL injection. For example, consider our previous PHP code for fetching a user input. So yeah, let's see. Without adequate security measures, an attacker could manipulate the color parameter of the executed malicious to execute malicious SQL code or SQL query. For example, instead of searching for a benign color, they might put or 1 = 1 as the input parameter, which would then transfer into the query. Select all from table ornaments where color equals space or 1 = 1, which basically means show me everything. Let's see, do we have our box up yet? Did it not turn on? I thought it... There it is. All right, that should be our website. Yep. So we got the website up. User input, we went through user input. SQL injection, we're already through all this part. All right, a caution around or 1 = 1. It's crucial to emphasize the potential risks of using the or 1 = 1 payload. With commonly used for illustration, injecting it without caution can lead to an unintended havoc on a database. When injecting or 1 = 1 into a query, the intention is to typically to bypass authentication or to return all the items in a table by making the condition always true, because 1 will always equal 1. However, the risks lie in that you might not be aware of the context of the scope of the query you're injecting. Additionally, applications may sometimes use values from an initial request in multiple SQL queries. SQL injection payloads that return all rows can lead to unintended consequences when injecting into different types of statements, such as update or delete. All right, is there anything we need in here? Injecting queries. Imagine injecting into a query that updates a specific user information, or let's see, or 1 equals 1 payload would make the condition true for every row, leading to a massive update affecting all rows of users in the table. This lack of specificity in the payload makes it a risky choice for penetration testers who might inadvertently cause significant data loss or alterations. A safer example would be a more targeted condition based on a known attribute identifying the record you want to manipulate. For instance, Bob, and then apostrophe would update Bob's record while Bob would not. Okay, this will demonstrate the SQL injection vulnerability without putting the entire table's records at risk. Fortunately, the development team behind the Best Festival website has confirmed that the website does not run any unpredictable queries and has permitted us to use this payload to demonstrate the vulnerability. All right, that's stacking. So let's go ahead and test. So let's get into this. Testing SQL injection is a critical aspect of web application security assessment. It involves probing the application to identify vulnerabilities where the attacker can manipulate user-supplied input to execute unauthorized secure SQL queries. To continue our mission, let's navigate to the defaced Best Festival company website to see if we can identify vulnerable input that leads to SQL injection. If you haven't already, which we've already done, started, from here, visit, there we go, already on that. Navigating to the website as an end user to understand its functionality and offerings is a great place to start. This manual enumeration allows us to identify the areas of the application where the user input is accepted and used as SQL queries. This can include search fields, logon forms, and any input fields that interact with the database. You might need to navigate to the correct page containing the vulnerable content or component. Be sure to click on any buttons or links you find. Browse the website manually until you find a form that accepts user input and might be querying a database. After locating the gift search feature, we can confirm our suspicions by simply filling out the form. All right, so let's search. What do we got here? We've got a defaced website, that's for sure. We got Meet the Elves. There we got a gift search. Oh. There's our gift search. Oh, here we go. So age equals child, toys, and our budget is $100. Let's see what happens here. So now we do have a SQL query right here. Age equals child, interests equal toys, budget equals $100. After clicking search, the website redirects to the results. We can identify. So if we come in here and change this to 50. Get different. The underlying PHP code is taking in 3 parameters we specified for age, interest, and budget, and querying the database will retrieve. Now that we've identified the area of the website where users' input is accepted and used to generate dynamic SQL queries, we can test if it's vulnerable to SQL injection. To do this, we can alter the parameters and test the application, how the application handles the unexpected characters. To test the input fields, we could submit characters like single quotes or double quotes as special characters. So let's copy this and we'll we'll switch it up here. And now we get a database error, but we do have we do see that it's a Microsoft SQL ODBC driver 17. All right. So you now see an error message returned. The error message received is a huge breakthrough, as it gives us many details on the underlying database management system powering the website and confirms that the user input is unsanitized. This error message shows that the Microsoft SQL Server is the database manager due to the banners and the driver information between the brackets. The information we gather will soon help us. Error message enumeration is critical to SQL injection testing because it equips attackers with the valuable information for crafting more precise and effective attack payloads. Because of this, it's always essential to monitor and sanitize error messages to prevent sensitive information. All right. Although we don't have access to the source code at this point, we can visualize what the underlying PHP script might be. Go away. Okay. Let me turn. I like dark mode, but for whatever reason, TryHackMe likes to, in dark mode, not show everything. All right, so as seen above, that's our script. So let's attempt to leverage a SQL injection payload from earlier to inject our own code into it. So now we've got this code, and let's put it in here. So now we've got results equal age equals any age. This should give us basically everything, I would assume. Man, that's massive. That's a long list. Oh, hey, we got a big. Let's copy that. There's a flag. I don't want all of these. I just want the TryHackMe flag. There we go. The injection condition. So we're looking for. All right, here's the flag. Injection 1 equals 1 condition into the gift search form. What is the result? That's the result of. Oh, come on, man. There's that one. Manually navigate to the defaced website and find the vulnerable search form. Let's go back up. We got a lot to go through here. All right, so now we've got. By injecting our payload and commenting out the rest of the query, we can bypass the intended filter and avoid errors to retrieve all gift results, regardless of specific parameters. So that basically just gave us everything. We have successfully dumped the database table and returned all 636 rows of the page. This is a very simple example and a suitable proof of concept that the website is vulnerable to SQL injection. However, it is unlikely that the attacker who defaced the Best Festival company did so by returning all the gift results. Let's explore possible methods to execute on the system. Now we can do stored procedures. So stored procedures is actually stuff that's sitting within the database. As mentioned, stacked queries can be used to call stored procedures or functions. Within a database management system, you can think of stored procedures as extended functions offered by certain database systems, serving various purposes such as enhancing performance and security and encapsulating complex data logic. A Microsoft SQL Server stored procedure XP_command shell is a specific command that allows for executing operating system calls. Ooh, that's interesting. If we can exploit a stacked query to call a stored procedure, we might be able to run the operating system calls and obtain remote code execution. As we previously confirmed, the database system in our example is a Microsoft SQL Server. With that in mind, let's dive deeper into what XP_command shell is. All right. XP command shell. This is a system extended stored procedure in Microsoft SQL Server that enables the execution of the operating system's commands and programs within the SQL Server. It provides a mechanism for SQL Server to interact directly with the host operating system's command shell. While it can be a powerful administrative tool, it can also be a security risk if not used cautiously when enabled. Because of the known risks involved, it's recommended that this function is disabled on production servers, and it is by default. Okay. However, due to misconfigurations and legacy applications that require it, it's common to see it enabled in the wild. For example, suppose you have an HR management system that needs to export data periodically to a CSV file and upload it into an external server. Instead of using more secure and modern methods like SQL Server integration services or custom application code, legacy applications may have opted to rely on an XP command shell to execute system-level commands to export the data. While this accomplishes the same task, it poses a security risk and maintainably risks and grants excessive system access to the SQL Server. It is also possible to manually enable XP command shell in SQL Server through EXEC Queries. Still, it requires the database user to be a member of the sysadmin fixed server role or have the alter settings server level permission to execute this command. However, as mentioned previously, misconfigurations that allow this execution are not too uncommon. We can attempt to enable the XP command shell on the Best Festival Company database by stacking the following commands using the SQL injection we discovered. So we've got the execution of SP configured show advanced options 1, reconfigure XP or exec SP configuration exam and reconfigure. By injecting the above statement into the SQL Server, we'll first enable the advanced configuration option in the SQL Server by setting the show advanced options to 1. We then apply the change to running configuration via the reconfigure statement. Next, we enable the XP_command shell procedure by setting XP command shell to 1 and applying the change to the running configuration again. All right, converting these into a stack query. So let's copy this whole query. That way we don't have to type the whole thing out. Since we've got that stuff on the other page, let's go ahead and do this 10.10.202.13 or oh, come on. Open up a new web page. And let's paste this bad boy in here. This whole thing. So it opens up the gift results page, but it doesn't look like it shows anything. All right, by requesting the URL with these parameters, we should be able to execute the stack queries and enable the XP_ command shell procedure. With this feature enabled, we can execute any Windows shell command through the execute or exe statement followed by the command name. All right. Unfortunately, one of the caveats to this approach is that it returns the results as rows of text. This means that typically the output will never be returned to the user since the injection no longer occurs in the original intended query. Because of this, we often are in the dark as whether or not the injection worked or not. But there are ways to validate whether or not our approach is working. Okay. Let's confirm if we have remote code execution by attempting to execute the certutil.exe on the target machine. This command is a native Windows command line program installed as part of the certificate services. It's handy in engagements because it is a binary signed by Microsoft and allows us to make HTTPS connections. In our scenario, we can use it to make an HTTP request to download a file from the web server that we can control to confirm that the command was executed. To set this up, let's create a malicious payload using MS Venom, allowing us to inevitably upgrade our SQL injection into a shell into a more standard reverse. Okay, so we're gonna need to open this up, close here, and we're gonna want to create MS Venom. So MS Venom, Windows x64. We'll create a payload, shell underscore reverse underscore TCP. Did they really talk about MS Venom here? You could think of a reverse shell. MS Venom is a command line payload generation tool. It's part of the Metasploit framework. Yeah, we need to go through and kind of explain that. So MS Venom itself allows us to create this, and it's on the machine already. LH host. And then our IP address, the attack box is 10.10.148.42. 42. We're going to do listening ports. So the port that we want this to call back to, 4444. And we want to create an executable file. Output. We want to call this reverse.exe. And it should create that and then dump it. Note, change the ls argument on your to your tech box IP address. You can contain it by this will take a moment to generate, but once complete, you will have created a reverse.exe Windows executable file. There we go. With our payload created, we can set up a quick HTTP server. So just run a quick Python server, Python 3M HTTP server, and then we'll set, hey, back up. Server, and then we'll set it on port 8000. Start running that. By running the above commands, So let's go ahead and copy this. We'll put that in here and we'll paste that in here. And then our IP address, we want to, this is the IP address that we want it to call back to or talk to. And since we're on an attack box, 10.10.148.42. All right. Let's open up another page and let's run this on here. And basically what this did, what we've got in here is we've got the command shell we're running, cert URL. And now that we've got that plugged in, basically what we just did is we ran this to install. Let's see, by running the command above, we will set up a lightweight web server, which port 8000, that we can use to serve as our payload. All the files in our current directory, including the reverse.exe, will be served using this method and will be accessible for the Best Festival server to download. It's time to stack. So we did our stack by putting everything in here. The above SQL statement will call the cert.util to download the reverse.exe file from our Python server that we're running and save it to the Windows temp directory for later use. After requesting the above URL to execute the stat query, we should immediately know if we were successful by checking the output of our HTTP server. There should be a request for reverse.exe. So close that. There you go. So now we see in our Python server, we see that it actually went out to get reverse.txt. So we've got a connection there and it actually pulled it down. Great progress. We've achieved remote code execution and now have our reverse shell payload on the target system. All we need to do now is set up a listener. So let's set up Netcat to set up a listener on here. We'll open up a new window in Netcat, LP, and we'll make the port 4444 because that's what we set up here in our, where's it at? Back up here, that was our listening port. So we're going to turn Netcat on and we're going to start listening. So now that we've got a listener running, so now that we got the final step, now it's running. It's been previously saved to the Windows temp file. Now what do we need to do? Now let's go call it using our SQL injection. That's our new query. So now our new query for this site. Hey, where'd it go? There it is. Okay. So now let's open up another page here and let's dump this in. And basically what we've got here is now we're back to open up the GIFs PHP site. We're going to now run the command shell and we're going to execute the command shell and we're going to have it execute the reverse.exe file that we created. And that should then bring up a backend connection to the server. So let's run that. we should pull up our terminal. And now we're into the machine. So if we do dir, we should see something going on in here. Look at that. Now we're actually in the back end of the web server. We've got remote code execution. We can run, let's see, what's it want to do? It wants us to run who am I? Who am I? And it says we're netservices.microsoft SQL Server Express. With that, we now have a reverse shellcode connection into Best Festival. Now we're golden. And we can restore now that we've gained interactive control over the web server. Let's see if there are any clues to help us restore. Exploring the directories. All right, let's go down here. Before we do that, let's go down here and start this. Manually navigate to the defaced website and find the vulnerable search form. So we know what that one is because we're constantly on that. That's going to be gift results.php, right? I'm pretty sure. Is that not right? Manually navigate to the defaced website and find the vulnerable search form. What is the first web page you come across that contains the gift finding feature? Oh, that's going to be the result. So what's the actual page that we start out on? Scroll down here. Come on. Scroll, scroll, scroll. Let's go. Giftsearch.php. Giftsearch.php. There we go. All right. Analyze the SQL error message returned. What is the ODBC driver? All right. Well, we can just run anything. And if we come in here and probably just change a page to 1. Let's go back up here. We want to get our error message that we got earlier. Oh, here it is. So if we go in here and close this out, instead of changing age to 1, single quote. There's our error message. So it says it's ODBC. That's a long ODBC driver 17 for SQL server. All right. What flag is in the note file left behind? So now let's go back into our box that we got on the backside. And now we need to search around and find the note. Let's go see. Oh, what? Oh, come on. I'm going to get into our users folder, probably. Yep. Probably go to the administrator folder. I got a feeling that's not gonna. Oh, it did. All right. What do we got in here? Nothing in that one. Check the desktop. All right, so we got deface website.bat, note.txt, restore. All right, so if we do type, note.txt, type is just like cat. There is our let's say I received your Bitcoin payment. Thanks again for a speedy transaction. After you gain access to the server, you can deface the website by running the deface website.bat script in the user's desktop. Feel free to dump the entire database and steal whatever you want. What an employee. Great guy, great guy. After you've gained access to the server, let's see, if you need to revert the changes back to the original website for any reason, just run the restore.website or restore_website.bat. All right, let's put this on here. And that should be that flag. All right. What is the flag you received on the home page after restoring the website? All right, so now let's restore the website, and that is restore_website. Hey. Restore_website.bat. That should restore our website. Removing all the files and folders. Restoration complete. So now if we come back to here, and there's our restored website. Ta-da! All right. Day 10 complete. Nice little intro to SQL injection with a nice little remote code execution using MS Venom and creating our own little executable file. That was a fun little room. See what we've got coming up for tomorrow. Should be another fun day. All these rooms have been very informing, very quick and easy. I wouldn't say quick. Some of them have gone for an hour, so. Yeah.
Yes?
Yeah. So, after that, that's it for today. See y'all tomorrow.